some function of x plus a. All right, and let's deal with some examples. Let's just say f of x is going to equal to the square root of x. Okay. I notice this now will go inside the square root. So when you've got a plus or minus inside the square root, the graph is translated right if a is negative, or left if a is positive. Okay, let's take a look on this guy. So what I've done now is I'm going to create what's called a daughter function. So my new one, f of x plus a, is going to equal the square root of x plus a. And as you can see, a is just some number. This is inside of this thing. So if we take a look at our parent for a square root, it looks like this. So if a is negative, what this is going to do is shift this whole thing to the right a units. So instead of starting at 0, 0 now, it's going to start here and go over. So that's the effect of having a plus or a minus inside your operator. Okay. This one looks similar, but it's not quite the same thing. The difference is here being, notice this was inside, and here we're going to add it outside. And these are the kind of transformations you guys are used to dealing with. So the graph is translated up if a is positive, and down if a is negative. And again, we're going to deal with the same thing here, only here's my parent. And so what I'm going to do is, instead of shifting it to the right a units, because I'm subtracting, and in this case we'll let a be positive, I'm going to shift it up a units. So instead of starting at 0, 0, I will go up a units and then draw my graph. Okay? So inside the operator, like this one, is horizontal, outside is vertical. Okay, let's take a look at number 3 then. Here I'm just multiplying inside by some number. Now since it's inside the function, that means it's going to be horizontally. And the graph is stretched horizontally. If a is bigger than 0, but less than 1, which means it's a fraction. Okay? And that's going to stretch it if it's a fraction. Or compress if a is bigger than 1. Okay? And let's go back and deal with the same one we have been dealing with, which is the square root of x. And what this guy is going to look like is, again, here's my parent. And let's deal with an a which is greater than 1, which is going to compress it. So all of these points basically just get moved back here. And so my new graph now will look sort of similar, except that everything has been squished horizontally. All right, that's when it's inside. Okay, now let's take a look at what happens to it when it's outside. And again, there's a pattern appearing here. If it's outside, then it's going to compress it vertically. Okay, so this one, the graph stretches vertically if a is bigger than 1. And compresses vertically if a is between 0 and 1. Now you notice these work just the opposite, the inside and the outside on both of these. And again, let's take a look at this thing here. Here's my parent. Let's deal with a is going to be bigger than 1, which is going to stretch it, which means everything's going to be moved up. And so that's what it would look like. All right. Let's take a look at this one. You notice my negative is inside here. When it's inside, the graph is reflected over the y-axis. And again, we stick with our parent here, all right? But because it's inside and I'm reflecting over this guy right here, my new guy is going to look like this. I've reflected it over the y-axis. Okay, well this looks kind of similar, except it's on the outside. And this means the graph is reflected over the x-axis. All right, and I've actually drawn this one in red. So there's the outside. Now let's take this guy here, and again I'm going to still be dealing with the same parent, but I'm going to reflect it over the x-axis. So it's going to look like that. All right, now let's deal with absolute value. Okay, points in graph that are in quadrants 1 and 4. Are reflected across y-axis. And here they're returned to points in your parent. Points in quadrants 2 and 3 are removed. In other words, they're not there anymore. And this is when the absolute value is on the inside. And the absolute, well, and again, let's deal with my absolute value function. On this one's not the best one. I mean my square root function. You notice that this guy is purely in quadrant 1, which means I'm going to reflect across the y-axis, which means it's going to look like this guy up here in absolute value. Okay? Now, if you're dealing with something like the quadratic, which looks like this, and you did that, what this would look like is that all these points in quadrant 1 right here are going to be reflected across the y-axis, so they'll be over here. The original points in quadrants 2 and 3 are removed, so your transform function looks like that. All right, and let's take a look on the outside. Points, and again, these are your parent function points in quadrants 3 and 4 reflected across x-axis. Points in quadrants 1 and 2 do not change. So you don't do anything to it. Okay? So in this case, with this guy here, my reflected one would stay where it is. All right? All right, so that's what you need for this one.